Stop letting your model get stuck forever. Contrary to intuition, making the learning rate fluctuate periodically instead of just decreasing it is the key to escaping local minima and finding better solutions. Traditionally, training deep learning models involves gradually reducing the learning rate to fine-tune weights. However, cyclical learning rates offer a novel approach. By continuously fluctuating the rate between a defined minimum and maximum value throughout training, instead of adopting a fixed or exponentially decreasing value, this method systematically cycles the optimizer. This allows the learning rate to vary within a specific range, moving away from stepwise adjustments that might trap the model in suboptimal states. The most critical benefit is avoiding local minima. By periodically increasing the learning rate, the optimizer gains enough momentum to jump out of these shallow valleys that would otherwise halt progress and prevent convergence. We have seen this technique demonstrated successfully on the CFAR-Pfister-10 and CFAR-Pfister-10 and C-Pfister-10, 1FR-Pfister-20 and CFAR-Pfister-10 and CFAR-Pfister-10 and CFAR-Pfister-10s and DenseNets, as well as on the challenging ImageNet dataset with AlexNet and GoogleNet architectures. This systematic approach provides a more robust way to tune hyperparameters without manual intervention. It allows the model to explore the loss landscape more broadly before settling down for fine-tuning near the end of the cycle. Ultimately, allowing the learning rate to vary periodically leads to faster convergence and higher accuracy by preventing the optimizer from getting stuck too early in the complex landscape of deep neural networks. Have you tried cyclical learning rates in your own projects? Did it help your model escape local minima? Let me know in the comments and subscribe for more deep dives into machine learning optimization.